Hello, welcome back to my channel. In this video, we'll discuss about the functional group, the general formula, examples, suffixes and prefixes of different organic compounds given in the first column. You see, it is alkane. Alkane is otherwise known as paraffin. It contains carbon-carbon single bonds. General formula is RH, or you can say CnH2n plus 2. If n is 1, then example is C1H 2 into 1 plus 2, 4, CH4. If n is 2, then the formula will be C2H6. For alkane, the suffix is ane. Ane. There is no prefix for alkane. Ane means you will find carbon-carbon single bonds. For alkyne, there will be a carbon-carbon triple bond. Here triple bond is a functional group. General formula will be CnH2n minus 2. If n is 2, then example is C2H 2 into 2, 4 minus 2, 2, C2H2. If you will take this one as C2H2, there are two hydrogen atoms, C2H2. Then the suffix for alkyne is yne. There is no prefix for alkyne. For alkene, there is a carbon-carbon double bond. If there is a carbon-carbon double bond, then this carbon is bonded to two other hydrogen atoms. General formula will be CnH2n. If n is 2, then H will be 2 2s are 4. For alkene, the suffix is ene. If there is ene, there must be a carbon-carbon double bond. And there is no prefix for alkene. You can write alkyne as RC triple bond C R dash. You can write alkene as RC R double bond C R prime. You can take any alkyl group. Here R and R prime may be equal or different. Here all these four alkyl groups may be different, may be same. For amine, the functional group is NH2. NH. This part is connected to the carbon chain or alkyl group. General formula is RNH2, where R is an alkyl group. R is an alkyl group. R may be CH3 or C2H5, etc. If R is methyl group, then CH3NH2 can be an example. And for amine, the suffix is amine and the prefix is amino. Let me tell, why do you write amine and why do you write amino? Let us take an example. You see, CH3NH2, there is only one functional group. So it is the principal functional group. When it is the principal functional group, it should be written as suffix. So for NH2, the suffix is amine and prefix is amino. So we have to write amine. As it is the carbon chain, it should be written as meth, ane, cancel E, methanamine. So the name of this compound is methane amine. You see here amine is written after root word, so it is a suffix. You see here NH2 is the principal functional group, so it is written as a suffix. It is written after root word. Root word means number of carbon atoms in the parent carbon chain. How many carbon atoms? 1 carbon. As it is written after root word, it is a suffix. And here you have cancelled E because A is a vowel, so you have to cancel E, so that the name of this compound is methanamine. Now we have to think about the prefix of NH2 as amino. Why do you write amino? Suppose there are 2 carbon atoms. This carbon is connected to carboxylic acid and this carbon is connected to NH2 group. So this is the parent carbon chain, number 1, number 2. And this is the principal functional group. So it should be written as suffix. Then this functional group is treated as a substituent. Here it is a principal functional group in this compound, but here it is a substituent, so written before root word. Substituent, so written before root word. Before root word means it is a prefix. For NH2, the prefix is amino. So let me write amino. For 2 carbon atoms, it is eth. For carbon-carbon single bond, it is ane. Then for this group, it is oic acid after removing this E. So the name would be amino ethanoic acid. Here NH2 is connected to number 2, so 2 is written before amino by inserting a hyphen between this locant and this substituent, 2-amino ethanoic acid. You see the name is 2-amino ethane, remove E, ethanoic acid. Here amino is the prefix, eth is the root word, ane and oic acid are suffixes. 2 is the locant and this is the hyphen. And you see the full name of the compound is one word. First letter is capital. Here we have written two suffixes. This ane is known as primary suffix and this oic acid is known as secondary suffix. This is the principal functional group and this is ane. Ane for carbon-carbon single bonds. Other primary suffixes are ene and yne. So suffix is of two types, primary suffix, secondary suffix. Primary suffix is ane, yne. Secondary suffix is ol, oic acid, al, etc. Then for alcohol, the functional group is OH. You can write ROH or you can write CN S2N plus 1 OH. R may be methyl group, ethyl group. Let it be CH3CH2 OH. Suffix for alcohol is ol. Prefix for alcohol is hydroxy. Let us take an example. CH3, just remove one H and one OH will be added. After removing this H, just remove one H and add one OH. You will get CH3, CH2 OH. This is ethane, but this is an alcohol. 1, 2, so eth is there. For single bond, ane. And for this OH, this is OL. Just remove E. So the name is ethanol. If same OH group is attached to an organic compound having a functional group like COH, it has more priority. It has more priority because COH has more priority than this OH group. So COH is written as secondary suffix, but OH cannot be written as secondary suffix. OH will be written as a prefix. So you see there are two carbon atoms. So the root word is eth. For single bond it is ane. Then oic acid. Then for this OH, this is 2-hydroxyethanoic acid. 2-hydroxyethanoic acid. 2-hydroxyethanoic acid. Here hydroxy is written as secondary prefix. Eth is the root word. N is the primary suffix. Oic acid is the secondary suffix. So you see, for this OH, the suffix is ol and prefix is hydroxy. For ketone, the functional group is CO. In expanded form, we can write like this. It is a bivalent functional group because there are two bonds which are connected to two alkyl groups on two different sides. You can write like this also. This is known as carbonyl carbon. Carbonyl carbon. General formula will be R, CO, R prime. Here R and R prime may be same or different, but here R and R prime are not hydrogen atoms. CH3CO CH3. This is a ketone. Suffix for ketone is ONE. Prefix is oxo. Oxo for this oxygen. You see CH3 CO COH. This is the principal function group. So oic acid is written as secondary suffix. And for this ketone, we cannot write secondary suffix because this is a function group with higher priority and this ketone has lower priority. So this should be written before root word as prefix. When CO is written as prefix, it is oxo. It is oxo. So the name would be 2-oxopropanoic acid. This is propanoic acid and this is 2-oxo. So the name would be, let me write again, CH3 CO COH 1 2 3. This is the parent chain. For 3 carbon atoms, the root word is prop. For single bonds, the primary suffix is ane. Then oic acid will be written after cancelling E. E should be cancelled. Then oic acid. And for this O, it is oxo. And oxo is written at number 2 position, so 2-oxo will be written. 2-oxopropanoic acid. This is 2-oxopropanoic acid. You see, oxo is the prefix for ketone and ONE is the suffix for ketone. So for this compound, the name would be CH3COCH3 propanone, PROP prop for 3 carbon atoms, 1 2 3. Then ANE propane, remove E, then ON is written after E, then propanone. For aldehyde, the functional group is CHO. C double bond O H. C double bond O H. General formula RCHO. Example HCHO. Next homologue CH3CHO. Here R can be a hydrogen atom. Suffix for CHO is al and prefix is formyl or oxo. For CHO, the prefix is formyl or oxo, but the position for formyl is different and the position of oxo is also different. Let us take an example. You see, this is RCHO. This is an aldehyde. If R is H, then this is methane, methanol. If it is CH3CHO, then this is ethanol. Eth, an, al for CHO. If it is bonded to a carboxylic acid, then this is the parent chain. 1, 2. For 2 carbon atoms, the root word is eth. For COH, the suffix is oic acid. Between root word and this secondary suffix, primary suffix will be written for this carbon-carbon single bond, that is ane minus E plus oic acid. And prefix is written before root word. For this O, it is oxo, 2-oxoethanoic acid. Why 2? Because oxo group is present at number 2 position. So the name would be 2-oxo eth n oic acid, 2-oxoethanoic acid. 2-oxo eth n oic acid, 2-oxoethanoic acid. 2-oxoethanoic acid. Here for this O, the prefix is oxo. For this oic acid, for this carboxylic acid, this is the secondary suffix, and here COOH has higher priority than CHO group, so it is written as secondary suffix. A function group having higher priority is written as secondary suffix. And for your information, there would be one secondary suffix. You cannot write more than one secondary suffix. Number of prefixes are more, but number of secondary suffix is always 1. That is the principal functional group. Here this compound has 2 function groups, but it is written as secondary suffix and this is written as prefix. Then same CHO is written over here, but in a different style. This is the parent chain, 1, 2, 3, 4. Here the whole CHO group is written away from this parent carbon chain. So here oxo is not written. In this case, oxo is written for this O, but here for whole CHO it would be written as formyl. 1, 2, 3, 4. For 4 carbon atoms, the root word is but. For carbon-carbon single bonds, N is the primary suffix. Then COH is present at 1 and 4, so you can write dioic acid. Why dioic acid? Because there are 2 COH groups and the number of COH groups are at 1 and 4, so butane 1,4 dioic acid, and this CHO group is written as 2-formyl, 2-formyl butanoic, 2-formyl butane 1,4 dioic acid. Here formyl is written for CHO group, but here oxo is written for this O group because this carbon is counted in the parent chain. Here this carbon is counted in the parent chain, 1, 2, you see, eth. So this O is written as oxo over here. But here this C is not counted in the parent chain, away from the carbon chain. So for this CHO, the prefix will be formyl. So you get a clear idea about formyl and oxo. Then for cyanides, the function group is CN. You can write C triple bond N. You can write RCN. This is CS3CN. For cyanide, the suffix is nitrile. Prefix is cyano. For amide, the function group is CONS2. In expanded form, we can write CONS2. General formula RCONS2. Here R can be HCS3. If you write HCONS2, next homologue can be written as CS3 CONS2. For this suffix is amide and prefix will be carbamoyl. For acid chloride, the function group is COCl. In expanded form, we can write like this, COCl. General formula RCOCl. Here R can be HCS3 C2H5. R is an alkyl group or H atom. If R is H, then the first one is HCOCl. Next homologue will be CS3COCl. Second suffix will be oil chloride. Prefix is chlorocarbonyl. For ester, the function group is COR. In expanded form, it can be written C double bond O, OR. General formula RCOR. RCOR is an ester. Here R and this R may be same or different, so you can write R and R prime, no problem. Here R can be HCS3 C2H5, HCOCS3. Suffix is OAT, but this R group is written before root word. This R group is written before root word, alkyl group. You can see R, COOR. This R group is written before root word, alkyl, then root word plus primary suffix, then primary suffix minus E plus OAT. If it is CS3, COOCS3, then this group is methyl, then root word is eth, then primary suffix for carbon-carbon single bond ANE, then minus E. For ester, the suffix is OAT. So E cancelled, then the name would be methyl ethanoate. Methyl ethanoate. Methyl ethanoate. And for this ester, suffix is alkoxycarbonyl. Alkoxycarbonyl. This OR is alkoxy, alkyl, and this oxygen alkoxy, and this CO is carbonyl, alkoxycarbonyl. Then carboxylic acid, COH. In expanded form, it is COOH, C double bond O, OH. We can write RCOH as the general formula. Here R can be HCOH. Next homolog will be CS3COH. Suffix is oic acid. Prefix is carboxy. Then Nitro Alkane. This is treated as a substituent. General formula RNO2. Here R can be a methyl group, CS3NO2. Here it has no suffix, but prefix for NO2 is nitro. For this CS3NO2, it is nitromethane. For C2H5NO2, it is nitroethane. For ether, a group is there as O, it is a bivalent group, ROR, example CS3O CS3, or you can write CS3O C2H5. Prefix is alkoxy. There is no suffix. Here R O R dash. Suppose this is alkoxy, and this is alkane. Alkane is the parent chain, so it should have more carbon atoms than this alkoxy group. Or in some cases you will find both R and RO dash have same number of carbon atoms. For example, CH3, OCH3, this is methoxymethane. For CH3O C2H5, this is methoxyethane. You see, in methoxyethane, methoxy has one carbon, but ethane has two carbon atoms. Then alkyl halide. Halide means X bonded to R group, general formula Rx. R can be CH3X, C2H5X. Here X may be chlorine, bromine or iodine. And for X you have to write halo as the prefix and there is no suffix. CH3Cl, this is chloro, methane, chloro, here it is the prefix, meth is the root word, N is the primary suffix. So you see, root word tells number of carbon atoms in the parent carbon chain. After root word you will find primary suffix, then secondary suffix. Primary suffix means ANE, ENE or YNE. ANE means carbon-carbon single bond, ENE means double bond, YNE means triple bond. But secondary suffix is OL, oic acid, amine. And secondary suffix is the principal functional group. Before root word you will find primary prefix, that is cyclo. If you have written cyclobutane, here cyclo is written before root word. This is the primary prefix. Before primary prefix you will find secondary prefix. This is chloro. This is also a secondary prefix. So you see one thing, suffix is of two types, primary suffix and secondary suffix. Primary suffix is ANE, ENE, YNE. Secondary suffix is OL, oic acid, the principal function group. And prefix is of two types, primary, secondary. Primary prefix is only cyclo, but secondary prefix is 2-chloro, 3-ethyl, etc. Here 2 is the locant, locates the position of substituent. Locant locates the position of the substituent. Or you can say, in some cases, locant also locates the position of substituent or function group. One thing I want to tell you before ending of this video, here R is an alkyl group, that is CN H2N plus 1. If one H atom from alkane is removed, this is CnH2n plus 1 alkyl group. If N is 1, the formula is C1H 2 into 1 plus 2, or you can say CH4. After removal of H, you will get CH3. This is methane and this is methyl. If it is ethane, you'll get ethyl. Another one thing I want to tell, if a carbon atom is bonded to 4 carbon atoms on 4 different sides, that is a quaternary carbon atom, and it has no quaternary hydrogen atom, or you can write 4-degree carbon. If a carbon is bonded to 2 carbon atoms on 2 different sides, that is a secondary carbon atom. The carbon atom in the middle is the secondary carbon, and it is bonded to 2 hydrogen atoms, so it has 2 secondary hydrogen atoms. It has 1 secondary carbon atom. And the carbon atom which is bonded to 1 carbon is a primary carbon. And the hydrogen atoms attached to primary carbon atoms are primary hydrogen atoms. It is also a primary carbon. If a carbon atom is connected to 3 carbon atoms on 3 different sides, it is a tertiary carbon. And the hydrogen atom attached to tertiary carbon is a tertiary hydrogen atom. Thank you for watching the video till the end.